September 14th through September 17th, Arithmetic with negative numbers. So, with NWEA timing being what it is, our timing this week is strange. This was supposed to be for Monday, but we're doing it today instead, thus the weird dates. Anyway, we're here to talk about negative numbers. Judging from what I heard on the PC yesterday, many of you are still unsure about what the rules are. Let's take a moment and review. But first, a definition. A negative number is less than 0. And let's take a second to figure out what happens when we combine them. One of the more common errors we see is students get this idea that two negatives make a positive. So if you have something like negative 2 minus 3, they try to write 5. But that's just not true. We could try to have you memorize some rules about adding and subtracting negative numbers, and the sign may or may not change depending on which is bigger. But a simpler way is to learn negatives via the number line. So here's our trusty number line. The middle is the origin, and that's where 0 is. Anything here to the right, positive. Anything to the left, negative. And there are two main ideas here. If we add something, then we're going to be moving to the right on the number line. And if we subtract, we're going to be moving to the left. No matter where we start, that rule always holds true. So if we start with a number like negative 4, we can plot that on our number line. And if we're adding 3, that means we are traveling to the right 3. And our final destination is negative 1. The reason why our number is negative is because we are still to the left of 0, and anything less than 0 is negative. Let's revisit a problem where we have a negative number minus something, or subtraction from a negative number. The steps are the same. First, we're going to plot our point on the number line, here at negative 3. And because we are subtracting, should we move to the left or to the right? If you said left, that's correct. I take 5 little jumps, and you'll notice my answer is negative 8. So for adding and subtracting, it's not true that two negatives make a positive. So how about multiplication or division? Well, if we take any two numbers and we multiply or divide them, you can follow a couple of rules. If they have the same sign, their product or their dividend will always come out positive. For example, negative 3 times a negative 2 is going to come out as a positive 6. In the same way that 4 times 2 will come out as a positive 8. So, same sign being multiplied, negative and negative, comes out positive. Same sign being multiplied, positive and positive, comes out positive. So what about when you have different signs? Turns out that's always going to be negative. For example, a positive 7 multiplied by a negative 3 is going to come out to negative 21. The first one is positive, the second one is negative, different sign, they come out negative. Does it work for division too? Absolutely, the same way. With that out of the way, let's take a moment and try a few of each type before we move on. For example, if you take negative 4 plus 6, what do? Start by plotting a point at negative 4. Count 6 to the right, because when you add, that's the direction you move on the number line. You move to the right. Where do you end up? A positive 2. Alternately, you could think of this as 6 minus 4. If you change the order of the numbers, that might be easier to understand. Let's try that trick on the next problem. Instead of negative 3 plus 8, let's change the order. You can do that. And the new problem becomes 8 minus 3. Well, I imagine that's a little bit simpler, but you could start over here at 8 and move 3 to the left, because when you subtract, you head to the left, and you see that we end up on 5. So let's try the same approach, but now we're adding and subtracting 3 different numbers. We begin here at negative 2, And when we subtract 4, that means we had left 4. So now we're at negative 6. Then we add 8. So I go to the right, 8. You'll end up at 2. Notice, in one problem you might take 2 different hops. 4 to the left, 8 to the right. But as long as you start in the right place and go in the right direction, your final answer will be correct. Next up, let's consider when we multiply two numbers that have a different sign. So there's a negative times a positive. That's always going to come out negative. So if you remember that 2 times 1 is 2, we know this is negative 2. But what about when there's 3 numbers instead of 2 numbers? Do they all have the same sign or different signs? There's 2 different approaches. You could go left to right and deal with 2 numbers at a time. So change this to 2 times a negative 3 first, which we see they do have a different sign. So that's going to give me a negative 6. And then you take the next step and multiply your result by the negative 1. We see these 2 numbers have the same sign, so it's going to come out as a positive 6. And that would be my final answer. Another technique is to count how many negative numbers you are multiplying. I have 2 different negative numbers here. If you have an even amount of negative numbers, your answer is always going to come out positive. The reason being that each pair of negatives cancel each other out. So we could just take 2 times 3 is 6 times 1 is still 6. And we know our final answer is going to be positive because there's an even number of negatives. Let's jump over to negative 4 times negative 1 times negative 2. I'll solve it using both methods. Negative 4 times negative 1. These 2 numbers have the same sign. It's going to come out positive. I get a 4. If I carry that down and I multiply by the next step, I'm going to multiply by a negative 2. These 2 numbers have a different sign. It's going to come out negative because a positive times a negative comes out negative. So I get negative 8 for my final answer. Or I could count how many negative numbers am I multiplying. 3 of them. Is that even or odd? Well, 3 is an odd number. So I know my product is going to come out negative. 4 times 1 is 4, times 2 is 8, and I know it's going to come out negative. Let's look next at a problem like 6 times 2 divided by 4. And just to show you, or to illustrate a point, let's change this problem a little bit and say that it reads 6 divided by 2 times 4. Similar, we're just changing the order. We're dividing first, then multiplying. The reason why is this is one of the most common mistakes that students make. If you think back to order of operations, what's the acronym that you've learned since elementary school? Please excuse my dear Aunt Sally. In that acronym, M comes before D. So oftentimes students will think, I do my multiplication first, 2 times 4 is 8, and then I do my division, and this is my answer. If I wanted to reduce, 3/4. Does that look right to you? I'll tell you it's not. If we follow the order of operations, parentheses comes first, then exponents, but multiplication and division happen at the same time. So to determine the order, we go left to right, just like if you're writing or reading. The same thing is true of addition and subtraction. You go left to right. So in a problem like 6 divided by 2 times 4, multiplication and division happen at the same time, so we go left to right. If I take 6 divided by 2, I would get 3. And then if I multiply that by 4, I would get 12. The reason being, Same sign comes out positive. Same sign comes out positive. But what about a problem like -5 times 4 divided by 10? You just told me that multiplication and division happen at the same time, and I should go left to right. Well, which one would happen first if I go left to right? It can be hard to tell with problems like this, and I'll tell you why. There are invisible parentheses on top of this fraction. We know that because the fraction bar is underneath -5 and it's underneath times 4. So therefore, we are supposed to multiply first and then divide. Contrast this with -5 over 10 times 4. Notice the fraction bar ends and times 4 is separate. Everything above the fraction bar here happens first because there are invisible parentheses. It has baffled Algebra 1 students for years. Keeping that in mind, let's solve this problem using both techniques. If I did -5 times 4 first, if I only deal with two numbers at a time, one is positive, one is negative, different sign, so I know it comes out negative. And then if I take -20 divided by 10, again I have a negative number divided by a positive, different sign comes out negative, and my final answer is -2. If I wanted to ignore signs throughout the problem, I could begin by asking, how many times am I multiplying or dividing by a negative number? And the answer is just once. The 5 is the only one that's negative. Is 1 an even or odd number? It's odd. Therefore, I know my final answer is going to be negative. So I could just take 5 times 4, get an answer, and divide that by 10, and get an answer. And I know it's going to come out negative. Whichever technique works for you.